The world is divided into two subcategories: the swole and the non-swole. Today we test to see how often each category pulls chicks based on their physique. We will compare both of them with a two-way table. A two-way table is a way of displaying frequencies or relative frequencies for two categorical values. Let's start by making a two-way table using random given data. Category 1, swole or non-swole, is represented in rows. Category 2, which is pulls chicks or does not pull chicks, is represented in columns. The bottom right total represents the total survey population of 40 surveyors. The other totals in the right column and the bottom row represent the totals of each specific conditions, and those are called marginal distributions. Let's try an example. What is the probability that you randomly select a swole person that does not pull chicks? Using the table. First, you think of it as a fraction, so the probability of swole, given that they do not pull chicks, means swole divided by does not pull chicks. Using the table, we can find that the probability of swole, given that they do not pull chicks, is 17 out of 22. You find 17 out of 22 by first looking at the does not pull chicks total, because it is given that the selection does not pull chicks. Then you look up towards the swole column and find the corresponding swole number, which is 17, making the fraction 17 out of 22. Now let's try the opposite example, which is what is the probability that the selection does not pull chicks given that they are swole. Now, since we are given that the selection is swole, we look at the swole total, which is 20, and the corresponding does not pull chicks number, which is 17, making the fraction 17 out of 20. Alright, now that you already know what two-way tables are, let's talk about independence.
Wait. Hold on, Peter. So, do you mean this independence?
No, cut that.
Oh my god, dude. Okay, so you weren't talking about the 4th of July, like with all the fireworks, the bald eagle, my homeboy George Washington.
No, I'm talking about independence in statistics. Independence is where event 1 is not affected by event 2. An example of independent events would be landing on heads after tossing a coin and rolling a 5 on a single 6-sided die. Both of those do not have effect on each other's probability. The formula for independence is the probability of event A and event B is equal to the probability of event A times the probability of event B. If the probabilities equal each other, then the events are independent. If they do not, then they are not independent. Let's try the example. Is being non-swole and not pulling chicks independent events? So our formula would look like the probability of being non-swole and not pulling chicks is equal to the probability of being non-swole times the probability of not pulling chicks. So now we find the probabilities of each event using the two-way table we made earlier. The probability of being non-swole and not pulling chicks is 5 out of 40. The probability of being non-swole out of the whole sample is 20 out of 40. And the probability of not pulling chicks out of the whole sample is 22 out of 40. We then simplify the fractions into decimals, and we find that the probability of being non-swole and not pulling chicks is not equal to the probability of being non-swole times the probability of not pulling chicks, which means that both events are not independent. And this concludes the analysis of being non-swole and swole and if they pull chicks or not, and the results found that all girls are the same. You're just going to get your heart broken.